a ball is kicked from a cliff top. Now it's there, and it goes down into the sea. It says the height h meters of the ball relative to the cliff top after t seconds is given by. So what that really means is the height of that ball at any time can be worked out if you do 12 times the time, take away 5t squared, 5 lots of the t, the time squared. So for part A, it's only 1 mark, so it can't be a difficult question, so we'll just read it. It'll be probably a straightforward substitution. Calculate the height of the ball above the cliff top after 2 seconds. So basically what they're doing is they're telling me that t is equal to 2, and I've got to work out what h is. So h is equal to 12 times 2 minus 5 times 2 squared. 2 12s, 24. 2 squared is 4, 5 4s are 20, so that's equal to 4 meters. So just a straightforward substitution for that 1 mark. Now, the question goes on. It says the graph below represents the height h meters of the ball relative to the cliff top after t seconds. So there's the height, and there is the ball getting thrown. Down here, remember, that's the sea. It says the sea is 17 meters below the cliff top, so that's the sea down here. That's it there. After how many seconds will the ball hit the sea? Right, so what are they telling me here? They're telling me after how many seconds will the height of that ball be at negative 17. So 4 marks for this one because it's a harder calculation. So basically we've got to work out the time taken for the height of this ball to reach negative 17. Now, we've only got one equation there, it's there. The equation we've got is the height is equal to 12t minus 5t squared. So they want to know what t is when h is negative 17. So we put minus 17 in there for the height. That's equal to 12 times t minus 5t squared. And I've got to work out what t is. This is your quadratic. So to solve a quadratic, we make it equal to 0, we factorise. So this is in the wrong order. I don't like that negative 5t squared, so I'm going to add 5t squared onto both sides. So I'll get 5t squared over here. I'm going to take away 12t from both sides. And the negative 17 is just going to stay there. And that equals 0. So now I've got a quadratic. I've got a positive squared term. So that's okay. I can work that out. I can factorise that. Numbers in this one are a wee bit bigger, but we'll see how it goes. So we're looking for factors of 5 times 17, and it's negative. So we're looking for factors of negative 85. Now, go through your factors. 1 and 85. 2 doesn't divide into because it's not an even number. 3 into 8. 3 would go twice and 2 left over. 25 is not a 3 times table, so it doesn't divide by 3. 4 doesn't divide into it. 5 does. Now 5, we did 5 times 17, so I'm just going to do 5 and 17. Now I'm looking here, that's negative, so factors have got different signs. I'm looking for negative 12. So if they've got different signs, the one really that I want to use is negative 17 and plus 5. That would give me my negative 12. So take your time and go through that. The numbers weren't easy in that one. Okay, you just got to take your time and go through them. So we're going to factorise that now. So we've got 5t squared. If you've got one factor that's positive and one that's negative, always write the negative one first. So that's going to be negative 17t, 5t minus 17, and that's equal to 0. So there we've got 5t squared, minus 17 plus 5 gives me negative 12, and the negative 17 is there. So we know that we've got it all correct so far. Split it down the middle, take out your highest common factor, which is t. That leaves me 5t minus 17. Now I've already got 5t minus 17 there. So what have I got to multiply all of that by? Plus 1. And that's equal to 0. So put your brackets together, so you get t plus 1. And you get 5t minus 17. And if two brackets are multiplied together to give me an answer of 0, then we take each one in turn and make it 0. So t plus 1 is equal to 0. or 5t minus 17 equals 0. Take 1 away from both sides, so t is equal to negative 1. 5t, add 17 onto both sides, divide by 5. So for that one then, we would have t is equal to 17 over 5. Now we're going to look at those two answers. Time, negative 1, that's not valid. Can't get negative time. Okay, so not valid, not a solution. Write something in there. So therefore, it must be at a time of 17 over 5 seconds. You can leave it as a fraction like that, even although you know 5 into 17 goes 3 times. 3 5s are 15, there's 2 left over. You don't need to change it to a mixed number, that's fine, keeping it as that top heavy fraction, but make sure that that's cancelled down. So that's your 4 marks. When you've got quadratic questions, there's only certain things you can be asked to do. You could be asked to work out a maximum height, that's your turn-on point. You could be asked to work out your roots where it crosses the x-axis, or you could be asked to substitute something in. There's not anything else they can ask you to do. Right, here's another one. So it says a diagram below shows the path of a small rocket which is fired into the air. The height, h meters of the rocket after t seconds is given by ht is 16t minus t squared. So it says after how many seconds will the rocket first be at a height of 60 meters? So there's 4 marks for this, so it's not just a straightforward substitution. It must have a bit of work to do in this one. So we'll gather our information. So for part A, it says after how many seconds will the rocket first be at a height of 60? So they're telling me h is equal to 60 meters. Go to the equation that they've given us. So h was equal to 16t minus t squared. So that's got to be equal to 60. This is my quadratic equation. I want to rearrange it to have a positive squared term, and I want to make it equal to 0. So I'm going to add t squared onto both sides, and I'm going to take away 16t. So when I do that, I get t squared minus 16t plus 60 equals 0. So that's my quadratic equation. Now, what do we do with quadratic equations? We factorise them and we solve them. So I'm looking for 2 numbers that multiply to give me plus 60. So 60 is quite a few factors, so it's 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So what do we know? They've got to have the same sign. Factors have got to either both be positive or both be negative. The fact that the middle term is negative tells me they're both negative. So there's my options all there. They've all got to be negative, and I want to find out which pair of them gives me negative 16 when I add them together. And the pair is negative 6 and negative 10. So we'll factorise that. So that would give me t squared minus 6t minus 10t plus 60. Now, I've also said before that if you've got one factor that's negative and one's positive, always write negative one first. Both of them are negative, so we don't have that option. We just have to go with it. So we're going to split that right down the middle. What's my highest common factor there? It's t, so it's t bracket t minus 6. Now I know the bracket's got to be t minus 6. So I'm going to compare t and negative 10t. So it must be minus 10 that comes out there. Now just check it. Negative 10 times t is negative 10t, negative 10 times negative 6 is plus 60, so I know that I'm okay. Make them into our 2 brackets, so t minus 10, and we've also got t minus 6. Both of them multiplied together gives us 0, so make each one of them equal to 0, so t minus 10 equals 0, or t minus 6 equals 0. Rearrange those 2b equations, and we get add 10 on both sides, so t is equal to 10 and t is equal to 6. Now it says when will it first be at a height of 60? So it's at height 60 twice, at 6 seconds and at 10 seconds. So say 60 meters is there. I'm just drawing that on the graph. It's going to hit there, and in that case, if that was drawn in the graph, that time there would be 6 seconds and that time there would be 10 seconds. So the first time that it reaches 60 is after 6 seconds. So part A is 6 seconds. Now, we've got another bit to do. For 3 marks, so there are quite big marks in this question, so they're a wee bit more complicated. This one here, it says, will the rocket reach a height of 70 metres? Justify your answer. Right, so there's the maximum height there. So that maximum height is at your turning point. That's your turning point there. So how do I find the turning point? I can either complete the square, or else I can say, well, it's halfway between the roots. And at this point, I am going to take out this bit for question 8 because we don't need that anymore. And I don't want to complicate it. So we need to find the roots and then find halfway between them. So how do we find the roots? When does it cross the x-axis? When y equals 0. So in this case, what we've got is, that's like y and that's your x's. So we've got 16t minus t squared has got to be equal to 0. Anything with a squared term in it, factorise it. Common factor is t, so that's going to be 16 minus t, and that's equal to 0. So either from this bracket, t equals 0, or 16 minus t equals 0. I don't want that negative t, so I'm going to add t onto both sides. So 16 is equal to t. So that's the same as t is equal to 16. So there is a 0, the root there, that's that one. So this one must be 16. So the turning point lies halfway between them. So halfway between 0 and 16, half of 16 is 8. So it's got to be at a time when the time is equal to 8. So we've got a maximum height when t equals 8 seconds. Now, how do I find out that maximum height? What's the formula for the height? The formula for the height was given up there at the start of the question. So height is 16t minus t squared. So height is equal to 16t minus t squared. I now know that the time was equal to 8. So it's 16 times 8. Take away 8 squared. And when I work that out, I get 16 times 8 is 128. And 8 squared is 64. When I take them away, I get 64 metres. So basically the maximum height is 64. What did they ask me? Will the rocket ever reach a height of 70 metres? No, it won't, because the maximum height there is 64. That's up there at 64, and that turning point would be 0.864. So you have to explain that to justify your answer. So you would say, since max height is 64 metres, the rocket will never reach 70. So that's all about your turning point there for that one. So for this one, I've changed the numbers in the last one, okay, and it's really just to give you a bit of practice. So pause the recording, see if you can do that one, and then after you've done it, I'll go through it, play the recording again, and you'll see if you're correct or not. Right, so what have we got? The diagram shows part of a path of a rocket. The height is 12t minus t squared. After how many seconds will the rocket first be at height of 20 metres? So they're telling me h is 20 metres. So we know that h is equal to, I don't need this t, so it's 12t minus t squared. So height is 20, so 20 is equal to 12t minus t squared. I've got a quadratic, we're going to make it equal to 0, but I want a positive squared term. So I'm going to add t squared onto both sides, and I'm going to take away 12t. So I'll get t squared minus 12t. There's a 20 already there, so we'll leave it, and that's equal to 0. So we want to factorise that, and I'm just going to do it quickly. You can do it out the long way. So I'm going to get t minus 2 and t minus 10. Okay, you factorise it properly. I'm doing it just quickly. So that means that either t minus 2 equals 0 or t minus 10 equals 0. So add 2 onto both sides, so t is equal to 2. Add 10 onto both sides, so t is equal to 10. So that means that this rocket reaches a height of 20 metres at 2 seconds, but then comes back to that height after 10 seconds. So for example, if that was your 20 metres there, there's the height at 20 metres, that must be 2 seconds. And then the rocket goes up and then it comes back down to that same height. And that time there must be at 10 seconds. That's what that means. So I'm going to take that out of there, okay, so we don't complicate the question. But that's basically what that means. So we have to answer that question. It says, after how many seconds will the rocket first be at a height of 20 metres? So it will be first at a height of 20 metres at t equal to 2 or after 2 seconds. Now the next bit, will the rocket reach a height of 40 metres? I don't know, there's the maximum height there. So I need to find this turning point. I could complete the square. That's not the way you normally would see it and you don't like negative. So what we're going to do is we're going to find the roots. We already see that one of the roots is 0. I want to find what this number is. And your turning point is going to be halfway between them. So we're going to, when it cuts the x-axis, we're going to make y equal to 0. So therefore, what we've got is, we've got 0 is equal to 12t minus t squared. I can factorise that the way it is. So it's common factor, take out t, so I've got 12 minus t. If two things multiply to give you 0, then either that bit of it, so that's just t on its own, so t equals 0, or 12 minus t equals 0. Add t onto both sides, so 12 is equal to t. So I've either got t equal to 12 seconds or t equal to 0. So I know there's a 0 and I can see it. So this time here must be at 12 seconds. Now I want to find the maximum height. Halfway between 0 and 12 is 6. So I want to find the height. So I'm going to write this down. So I want to find the height when the time is equal to 6 seconds, because that's where the maximum turning point will be. So height is equal to 12t minus t squared. T is 6, so 12 times 6 minus 6 squared. That's equal to 72 minus 36, which is equal to 36 metres. So the maximum height that this rocket reaches is 36 metres. So we'll now answer the question. Will the rocket reach 40 metres? Justify your answer. You say no, because max height is only 36 metres. Okay, so the next one, it says a rectangular, these questions would be at the end of a paper, and so you'll know they're coming towards the end, they're getting harder. A rectangular piece of picture measuring 9 centimetres by 13 centimetres is placed in a rectangular piece of card. So there's the picture in the middle, and there's the card round about it. So it says there is a border x centimetres wide on all sides of the picture. Write down an expression for the length of the card in terms of x. So they tell me that's the length. Now, I know that wee bit's x, but also know that bit's x. So we want to know what the length is. So it's x plus 13 plus another x. So it's going to be 2x plus 13. That's for 1 mark. Next thing is, it says, hence show that this whole equation, we've got a quadratic. Now, they're asking me to work this thing out, okay, and they're giving me it because I can go on and use that equation for the next part of the question, even if I can't find out what that is. So we have to think about what this is all about. So if I know that up and down the way it's 2x plus 13, going across the way I know that that's got to be x, and I know that that's got to be x, and the middle bit there was 9. So the breadth of it has got to be 2x's plus 9. Now, that's the expression for the length of the card, we've got it there. Hence show that this whole thing is equal to 0. It's really the area of your card. So area is equal to length times breadth, which is equal to 2x plus 13 times 2x plus 9. We'll use FOIL to multiply out this bracket. So first two terms is 2x times 2x is 4 x squared. And we've got 2x times 9, 2 9s are 18, so that's 18x. And then we've got 13 times 2x, which is 26x's. And then I've got 13 times 9, 9 10s are 90, 9 3s are 27. So 90 and 27 gives us 117. Now, I should have pointed out up there, I need to work out area because it says the area of the card is 270 square metres. Okay, so area, we're working out as length times breadth. And I tidy this whole thing up, I get 4x squared, and 18 plus a 26, that's 30, 44x, and we've got plus 117 at the end. Now, they told me in the question that the area of this card was 270. So area is 270, we'll fill that in. Now, that's a quadratic. I want to make it equal to 0. I've got a positive x squared term, so I'll leave everything there. The thing that I don't want to be here is this 270, so I'm taking away from both sides. So that'll leave me 0. And I've got 4x squared plus 44x's. And then I'm taking away 270 from that. And when I take away 270 from that, I get negative 153. So that's us, we've proved our equation. Now, they did give us that equation because if we can't manage to work that out, we're only losing those 2 marks, right? So if you couldn't work that out, you're losing those 2 marks, but you can still go on and get the 4 marks for the next bit. It says calculate x, the width of the board. They've given you your answer correct to 1 decimal place. When you've got a quadratic and it says find your answers correct to 1 decimal place, that's code for x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, what have we got? We'll get a is equal to 4, b is equal to 44, and c is equal to minus 153. Now I'm going to substitute that into that equation, and then I'll start the video again. Okay, I've substituted in all of those numbers. Use your calculator to work this out, and here's all the values, but you do it yourself. Pause the video and just check your numbers. Then I've split it into the 2 different answers, which is the one with the plus, the one with the minus. And when I do that, I get these 2 answers here. Now it did say in the question to 1 decimal place. That's going to be 2.8 to 1 decimal place. That there is a length. It can't be negative, so that's not a valid answer. So your answer is 2.8 to 1 decimal place. This video is going to be quite long, so what I'm going to do is I'm going to do it in 2 parts. So I'll call this Quadratic Equations 1, and I'll split it and I'll do other questions in another video.